Okay, guys, listen up because we got a tough one today. I wouldn't say that it's tough in the way that it's time consuming. It's not time consuming. It's just tricky. So let's write down our rules. If m is a multiple of 2, use the rule the square root of am is equal to a to the m divided by 2. For example, if you wanted to do this, like let's say with real numbers, if you have the square root of x to the 6th, that is going to be equal to x to the 3rd. Okay? And just to prove that to you, just think about what square roots do. Okay, if we have the square root of 81, we know that that's 9, because 9 times 9 is 81. So if we applied that logic that, this times this is 81, then this times this must be x to the 6th, and sure enough, x to the 3rd times x to the 3rd would be 3 plus 3, and it would lead me to my answer. Okay, here's where it gets tricky. If it is not a multiple of 2. So if it's even, easy, guys, cut it in half, right? But if it's not a multiple of 2, you can't do that. So the answer is a to the m is equal to the square root of a to the m minus 1 times a. This notation is a little weird to look at, but all we're really saying is that if we have the square root of x to the 7th, we can't apply the first rule and make it x to the 3.5. So what we do is we go the square root, and then we spread it out. So if it's not odd, we make it odd by dialing that back 1 and then writing the other piece of it. So the answer is, well, the square root of x to the 6th we can do, and then since we can't do the other one, the answer would be x to the 3rd times the square root of x. So let's just do a lot of these together, actually. So the first two are easy. You're cutting them in half, right? The square root of 9k squared is 3k, and that's because 3k times 3k would equal 9k squared. This one would be 8, P2. You get those. Okay, let's move into some of our odd problems. I did one just like 7. Okay, let's do 8. So for 8, I can do the a's. The square root of a squared is a, times, take this down 1, and now I have it split into 2, and I can cut b2 in half, which would give me ab times the square root of b. Okay, so that's good. That's the same kind. And then we get into this stuff. So for 13, could you turn there, please? We need to break this down like we did on Friday to 4 times 2 times x to the 6th. Might be a little clearer if I write this as times like that. And then, well, whatever you can take the square root of in there, take the square root of it. If you can't, you leave it. So the square root of 4 I can do, and the square root of x to the 6th I can do. The 2 I cannot do. I am done. Okay? Let's see. Are we good there? Let's do one with an odd number like 16. So what can we multiply together to get 45, where 1 is a perfect square? That would be 9 times the 5 times the n to the, well, I got to take this down to 10, and then I compensate right there. So I got the square root of 9. Anything else in there I can take the square root of? Well, n to the 10th. And then all I have to do is rewrite the stuff I can't deal with, which is 5n. So the answer is 3n to the 5th times the square root of 5n. So maybe write these with a little degree of separation there. Like I would go like times square root of 5n. You could even make it real clear like that. I just don't want to be thinking that that's a fifth root attached to the radical sign. What else do we got here? Let's do some bigger ones. Let's just knock out, let's just do a big one like 24, okay? So I'm just going to look at the answer key here to make sure that we get it right. Now for the bigger ones, actually for all of them today, I will have texted the answers to your substitute, Mrs. Broderick. Okay, so please be checking your answers with her because this stuff is just trial and error. Okay. So let's see here, 392. What can we multiply together to get 392 or 1 as a perfect square? Well, I could cut it in half. (196) times 2. And then times, this is good, right? This is good. But we have to dial C3 back to C2 times C. Okay, what in here do I like? I like the 196 because the square root is 14. I like a squared because the square root of that is a. The square root of b squared is b. The square root of c squared is c times the square root of anything I could not remove, which would be the square root of 2c. So work your way through 1, 2. You may scratch that one out. And then 3. It's a lot of practice, but like I said, it's not time consuming. It's just tricky. So practice makes perfect. So finish pages 1, 2, and 3. Work together. Check your answers with the substitute. And when you're done, please play Prodigy. I'll be checking from home to make sure that we're making progress with that. And that will be it. Thanks for listening, guys.